All right, so if you're a developer, you've definitely gotten used to AI coding assistants. You know, the little helpers that pop up with suggestions. But what's happening right now, it's not just a little help anymore. It's a massive shift. We're moving from a helpful assistant to a full-blown agent. So let's dive into what this new era of AI coding actually looks like.
And this slide, this says it all, right? Just a couple of years ago, we were impressed when an AI suggested the next line of code. Now we're talking about AI building a C compiler, 100,000 lines of complex code completely from scratch. The leap is just staggering. So, how on earth did we get here?
Well, it really all starts with one fundamental breakthrough: memory, or as it's called in the AI world, the context window. This is the secret sauce. It's the key that unlocks an entirely new level of understanding and capability for these models.
And here's the number that matters: 1 million. That's the number of tokens. You can think of them as pieces of information that a model like Claude Opus 4.6 can process all at once. It is a truly staggering figure, and it completely changes the game.
Okay, so what does a million token context window actually mean in plain English? Imagine having a developer with a perfect photographic memory of your entire project. Every single file, every function, every dependency, all of it, held in its working memory at the same time. It doesn't just see a piece of the puzzle, it sees the whole picture.
Now here's where it gets really cool. A huge memory is one thing, but can the AI actually find what it needs? This benchmark is literally called needle in a haystack. And look at that jump. The older model could only find the needle about 18% of the time. Opus 4.6, a whopping 76% accuracy. So it's not just holding all that information, it can recall it with incredible precision. So, you've got this incredible memory. What do you do with it? Well, you stop being a simple assistant and you become an agent. We're moving past just getting suggestions. We're now in an era where you give the AI a goal and it just gets the job done.
Let's be super clear about what we mean by agentic. This isn't just a chatbot that responds to you. It's an AI that can act. It can create a plan, break it down into steps, use tools like APIs or your file system, and work on its own to achieve some complex goal you've given it. It's proactive.
And this isn't some far-off future tech. It's happening right now. Just look at the features of the Claude Code Action on GitHub. It can review your PRs, implement fixes, add new features, and use tools all by itself right inside your workflow. It's basically a proactive digital member of your engineering team. Okay, one agent is cool. But what happens when the project is so complex that even a single super smart AI isn't enough? Well, that's when you build a team. And this is where things get really, really interesting. We're talking about multiple AIs working together in parallel.
Now, it's really important to get this difference. The old way was sub-agents. Think of a manager and a bunch of assistants who can only report back to the boss. The new agent teams paradigm is totally different. The AIs can message each other directly. They have their own separate contexts, and they coordinate among themselves. This is true parallel collaboration.
And if you need proof of just how powerful this is, get this. This is a real project. A developer gave a team of 16 Claude agents, one of the most famously difficult tasks in computer science, build a C compiler from scratch.
The results are, well, they're just mind-blowing. You have 16 agents working in parallel over 2,000 separate sessions. They ended up writing over 100,000 lines of Rust code. And the final product? A compiler that can actually compile the Linux kernel. A project that would take a human team months, done by AI. Just wow.
So how does this play out in a more day-to-day task, like a code review? It's like an incredible AI-powered assembly line. One agent does an initial check, another one goes and gathers all the context it needs. Then a team of 4 agents reviews the code at the same time. New agents are then created just to double-check the findings. And finally, one last agent reports all the validated issues. It's wild. Okay, this is all amazing technology. But how do you, as a developer, actually get your hands on this? Let's take a look at the current landscape and break down the different ways these AI agents are being packaged for us to use. Right now, the market has basically shaken out into 3 main camps. First, you've got AI native IDEs like Cursor, where the whole editor is built around AI. Then you have terminal agents like Claude Code, for those of us who live on the command line. And finally, you have extensions like GitHub Copilot, which plug into the editor you already use. When you put them head-to-head, the trade-offs become really clear. Copilot is the cheapest, and it works everywhere. Cursor probably has the slickest, most integrated experience, but if you're looking for raw power, The massive context window, the top benchmark scores, and that incredible multi-agent capability? Well, Claude Code is in a league of its own right now.
So, the real question is, which one is right for you? Well, it really just depends on what you care about most. If you live and die by your autocomplete, you'll probably love Cursor. If you're tackling those massive code-base-wide refactors, Claude Code's huge context window is unbeatable. And, if price is your main driver, or you need something that works in any IDE, Copilot is still a great choice.
As crazy as all this sounds, the pace is just not slowing down. In fact, just as we're starting to get used to these incredibly powerful agents, we've already gotten a glimpse of what's coming next, thanks to some recent leaks.
I mean, just look at this timeline. It's wild. In early 2026, Opus 4.6 launches with agent teams. And just a few months later, internal documents leaked describing the next generation, codenamed Claude Mythos. And the promise is a step change in performance.
And what does a step change actually look like? Well, the numbers tell the story. On this benchmark that measures complex, real-world coding, Opus 4.6 is already a leader at over 65%. But the expectation for Mythos is a jump into the 75 to 85% range. That's not just a small bump. It's a massive leap into a whole new tier of capability.
And you don't have to take my word for it. This quote is straight from that leaked document. They were calling it capybara internally. The claim, dramatically higher scores on tests of software coding. The people actually building these things are telling us that another revolution is right around the corner.
Which, of course, leaves us with the big one, the question that's on everyone's mind. We've gone from AI as a tool to AI as a teammate, and now we're right on the verge of AI as an entire team. So, in a world where AI can plan, execute, and collaborate on this scale, what's the new role for a human developer? I don't think it's going away, but it's definitely going to transform in ways we're only just beginning to imagine.